Okay, we will continue with condensation process under 5.2 liquid, a process whereby vapor molecules turn into liquid. In my previous video, I explained about vaporization process. Now we are going to talk about the vice versa of that process. In vaporization, liquid change to gas. In condensation, gas turn back into liquid. So this is the process called condensation process. Some of the vapor molecules may lose their kinetic energy during the collision. They do not have enough energy to remain as vapor molecules. This is after they become vapor. They escape as vapor, they will collide and they lose kinetic energy. And they don't have enough energy to retain or remain as vapor molecules. So they reach the surface of the liquid and trapped by the attractive forces. Now they return to the surface because they do not have enough energy to remain as vapor. Once they reach the surface, the molecules at the surface will trap them. If they cannot overcome the attractive forces, then the vapor molecules which have returned now become liquid molecules, and this process known as condensation. Now we go to an important term under liquid 5.2 is called vapor pressure. Vapor pressure is the pressure exerted by a vapor in equilibrium with its liquid phase. Molecules can escape from the surface of liquid at any temperature by evaporation. In an open system, vapor molecule which evaporate off will diffuse away. But in closed system, the vapor molecules which leave the surface are trapped inside the container. These vapor molecules are always in constant random motion. The molecules will strike the wall of the container and exert some pressure. As the quantity of molecules in the vapor phase increases, some molecules may lose energy and condense. Eventually, the rate of vaporization will be equal to rate of condensation. Now the system said to be in dynamic equilibrium. At equilibrium, number of vapor molecules above liquid are constant. The pressure exerted by those molecules are known as vapor pressure. Okay, the boiling process. This is another process. Increasing the temperature will increase the vapor pressure. As heat is applied, the vapor pressure of a system will increase until it reaches a point whereby the vapor pressure of a liquid system is equal to atmospheric pressure. Imagine in a closed container, there is a liquid and we heat the liquid. The liquid molecules eventually through through boiling process, it become vapor molecules. Once it becomes the vapor molecules, they will collide with each other. They will strike the wall of container. They exert pressure, and that pressure is known as vapor pressure of a liquid. When the vapor pressure of liquid inside the container equals to the external atmospheric pressure, the liquid inside the container will begin to boil. And that point is known as boiling point of that particular liquid. At this point, the change of state from liquid to gas occurs not only at the surface of liquid, but it also within the liquid, and bubbles also form within the liquid. This is the main difference between evaporation, and boiling. Evaporation or vaporization occurs only for the molecules at the surface, while boiling, the process occurs not only at the surface but also within the liquid. Now, boiling point, there is two important definitions you need to know. First is boiling point, temperature at which the vapor pressure of a liquid is equals to external atmospheric pressure, while normal boiling point, temperature at which liquid boils when the external atmospheric pressure is 1 atm. So there's a difference between two definitions here. Students must know what is boiling point, what is normal boiling point. The difference is atmospheric pressure. For boiling point, it can be any external pressure, but for normal boiling point, it has to be 1 atm.